Hello, and welcome back to Stats. Hope you had a good break. So for this week, we're going to continue looking at different contrasts, ways that we can kind of test an ANOVA. And we're going to continue using the same lab document, we're going to continue using the same data that we'd used in the past. Normally we would have also been looking at SAS at this point, using that, but instead we'll be introducing you all to SAS in a couple of weeks. It's another stat software that you'll become much more familiar with next semester. It's good to start getting used to it early. Okay, so for this week's lab, like I said, it's the same data as we had before. So this is what it looks like, all graphed out. We can see what the relationship is between drug A, drug B, and what the effect they have on anxiety. So last time we did this by hand. Today we'll look at how we can make these contrasts in SPSS. So instead of you having to do the work, what do you need to know to make SPSS do the work for you? So the first thing is we're going to be using something called an L matrix subcommand. Basically, everything to do these contrasts, we can't do them through the point and click menus like we've done up to this point. Instead, we have to actually go in to the syntax and write some syntax for it. I know that this might be confusing for a little bit, but just bear with me. Hopefully it'll make more sense at the end, and we aren't making you write syntax without any knowledge, so don't worry. So the L matrix command is for between subjects factors, and we're going to actually be doing repeated measures factors pretty soon. So that's going to be, I think, either the next lab or the one after. So we're going to get into that. Don't worry, even more fun for you. So the first thing to know is that, well, when we're looking at these contrasts, there's three different ways we can look at it, right? We can collapse all of the different factor B's and just look at factor A, so 1, 2, and 3. We can collapse factor B and we can collapse factor A and just look at factor B, so the average of the green line, the average of this yellow line, the average of the blue line. Or we can look at the interaction. So each of these dots compared to each other. The problem is that SPSS might have a different idea of the order those dots should go in. So it's easy, or if we're just looking at factor A, we can say, okay, level 1, which is no dose, versus level 3, which is high dose. But when we're looking at the interactions, now is factor A3B1, is that going to be the third, like the third number, or is it going to be like the sixth? And so essentially what we want to know is what order does SPSS think of these things in. And that's what this table is for. Now you can get it by add this print subcommand to a typical ANOVA. So if we say print test L matrix, it'll give us this. All this is telling us is what order. That's all we care about from here. So see this L8, L9, L11, L12. We care zero about these, at least right now. Doesn't matter to us. Means nothing. Instead, we can see, okay, so first it has, so there's A1, A2, A3. Good. B1, B2, B3. Good. So that's normal. We expected those to go in numerical order. Then we get to the interaction, so the specific dots. So we see, okay, first is A1, B1, and then it goes A1, B2. So remember, it could have gone A2, B1, or anything else, really. So really all we're getting from here is what order is SPSS reading these cells in. Now, why this is important is because our syntax is going to end up looking something like this. See, we're not saying this 0 is for A1, B1. We just write what we want the contrast coefficients to be for all of the cells in order. Right? So we need to know what that order is. So here, this is going to be pretty similar to the contrast that we did last week. So first, we're saying, okay, looking at just A3, B1, let's compare that to A3, B3. Okay, so going back to this, I'm very much a visual person, so A3, B1 versus A3, B3. So we want to compare the bottom blue dot to the top yellow dot on the far right. So how do we write this out? Well, this is what the syntax is going to look like. So first, there's the L matrix command. What comes after this is just the title. This is just us reminding ourselves what we're looking at. Next, we have drug B. Drug A doesn't matter here because, well, drug A is constant for this, right? It's A3 in this one and A3 for this one. So we don't need to worry about it because it's just constant. So we don't put that in. But drug B, we have, okay, it's going to be the 1 versus 3. But it's more specific than that too, right? It's not just all of B1 collapsed across A's position, not versus all of B3. No, it's just A3. And so to accomplish this, we add in this interaction clause. So drug A by drug B. Here is where we're starting to look at individual cells. Okay, so looking at individual cells, and so all of these zeros are saying ignore all of these cells. Remember, these are the same as those contrast coefficients that we were dealing with last lab. So all of these cells ignore. We just want A3B1 versus A3B3. Again, we know that this last one is A3B3, and this third to last one is A3B1, because here you can say, okay, this last thing here is A3B3. And if we look back, okay, here's the third to last, and it's A3B1. So remember, all this is telling you, this table is telling you, is what order do I need to put my contrast coefficients in. That's all it's telling you. Now let's look at another example. So we can also look at A3B1 and compare it to A3B2. So again, back up to here, A3B1 to A3B2, well, that's on this far right, this blue compared to the green. So we first looked at the blue compared to the yellow, now we're looking at the blue compared to the green. And so, as you'd expect, this is what that would look like, right? So now we're comparing 1 to 2, and so in the 1 position, -1, in the 2 position, it's 1, ignoring the 3 position, and then, again, we're ignoring all of these cells, now we're ignoring the last cell, and just looking at these two. And we can take this one step further. So we did A3B1 to B3 and B2. Now let's look at A3B2 versus A3B3. So that's the final comparison here. So the green versus the yellow. So essentially we're just comparing all three of these points to each other. So that's how that would look. Again, same thing as before. Okay. Then finally, another thing that we might want to do is say, okay, the next biggest difference on that plot that we were looking at would be A1B2 compared to A1B3 and A1B1. So for this one, it's saying, okay, over here in the A's, A1, so on the far left, is the difference between this green dot. Is there a significant difference between this green dot and the blue and the yellow? Now, the blue and the yellow are basically on top of each other, so let's count them as combined. Now this is very similar to some of the things that we did last week as well. So here, remember, these contrast coefficients just need to equal out to 0. So, since we're doing these two combined, let's say it's negative 0.5 and negative 0.5 with 1. Does that matter compared to doing it negative 1, 2? No. Or 1, 1, negative 2? No. Remember, it just has to equal out to 0. And then, again, so because we're looking at drug B, when we hold drug A constant, that's in here. And then we're also looking at the interaction, because we're looking at just those specific cells. So, again, this order comes from the table above. We have a final type of comparison that we're going to look at here. Up until now, we've only been doing simple comparisons. Even this last one, where we're combining two, that's still a simple comparison, really, right? It's not an interaction contrast, because A is constant, right? That's why we only see drug B up here, because A is constant. For this last contrast, I want to instead do an interaction, you know? So a benefit of doing these interaction contrasts is that, well, we actually get to compare multiple points together. Remember, it's once we start doing these interaction contrasts, instead of seeing is there a difference between these 2 points, instead we're looking at is there a difference between these differences? Or, put another way, are the slopes between these points different? So, for this, we're going to look at the most extreme cell differences. So here, there's different ways that you can determine this. But what we're going to do is look at this table. So here, this is a table just with all of the means and marginal means, right? So on the side here, this is, so 6.72 is the average for drug A, no, if drug B is constant. So across all these conditions, this is what the average value would be. And similar down here. So drug B, no. If drug A is being constant, being held constant, so all of these things are collapsed, the average would be 6.4. Now when we look at this table, what we can do is we can decide, okay, where are the biggest differences? And it can be confusing to look into here sometimes because, well, I mean, this one's pretty low, right? It could be possible that this one was lower than this. Whatever. Essentially, you might not end up with a nice rectangle, which is what we need. Instead, we look at these marginal means. So over here. So this is saying, okay, what's the biggest difference here? Okay, well, the lowest is for drug A, low dose. And the highest is for high dose. Okay, so let's compare these two. So for drug A, it's going to be low and high. For drug B, the lowest value is 6.4. And the highest is 9.67. So we're going to compare no and high. So all we did here was looked at a table that had the marginal means, which is the means collapsing across conditions for the other variables. Looked at the marginal means, and we chose the conditions in which the difference between these cells is the highest. Difference between the marginal means is the highest. So from that, we can say, okay, we're going to compare A2, B1, A3, B1, A2, B3, and A3, B3. So these 4 cells. Now, I'm not sure if you've done this in class yet, but in order to figure out what the coefficients are for this, we'd use a table, something like this. It's not always the most intuitive what these values should be, because remember, we're not averaging, we don't want to average this cell with this cell and compare that to this and this, because then that's not interaction anymore, right? That would be holding drug B constant. So instead, when we're making an interaction contrast, you want to make this sort of table. And so here we have no, low, high, no, low, and high for drug A and drug B. Sorry, I keep forgetting that you guys can't see my cursor. So if I'm saying things, I'm probably indicating them with my cursor and I just can't show you. So once we have these on the side set up, what we want to do then is assign each of them a value. So we said that for drug B, we were going to compare no dose and high dose. So randomly, we give no dose a 1 and high dose a -1. Remember that the order of negatives, like which one is negative, doesn't matter. It just changes the value of the final F. So it just is the direction. Does not matter. It could have been no dose -1, high dose 1. As long as across B, these coefficients equal out to 0. We're good. So then we do the same thing for here. Well, drug A, we're ignoring the no dose, right? We said that that's not being included. It's not where the biggest difference is. Instead, we're comparing low and high. Okay. So now we have this kind of initial set of values. 1 for low dose, -1 for high dose. For drug A, no dose 1, high dose -1 for drug B. What we do with this is essentially we're just going to times these values out based on the table. So if we look at no dose, drug A low dose, drug B no dose, well, 1 times 1 equals just 1. If we look at drug A high dose versus drug B no dose, -1 times 1 is a negative. Same over here. -1 times 1, -1, and then 2 negatives cancel out to give you 1. So that gives us what the contrast should be for each cell. Contrast coefficients, I should say. And you can see it's written out here for you as well. So the contrast coefficient for 1, 1 is 0, 1, 2 is 0, 1, 3 is 0, 2, 1 is 1, 2, 2, 0, 2, 3, negative 1, 3, 1 is negative 1, 3, 2 is 0, and 3, 3 is 1. Why does this work? You don't need to know. It doesn't matter. But it does. That's all you need to know, is that this is how you find the contrast coefficients. And it will give you the interaction contrast that you hope for. So with this, we can say that we're comparing the difference between these values. Or if I go back up to here, well, we're looking at factor A2, so this middle part, versus the high. Here, can I draw? So we're looking at down here, yes. So the blue compared to this yellow. So this one and this one. So how I like to think of it, something that helps me, is essentially, aside from just comparing these 4 points, ignore the green in there, what we're actually comparing here is this line and this line. Are the slopes of these lines significant? Because if so, that's probably where the interaction is coming from. Remember, we're doing this because we had a significant interaction, and so we're trying to figure out where that's from. So that's what we're trying to figure out. Are these slopes my mouse does not want to cooperate. I just changed the battery too. Do these slopes, there we go. Do these slopes, are they the same? Is the difference between these two bottom blue points the same or different between the difference between these top 2 points? When we're doing these interaction contrasts, it's all about the slope. So what that looks like, if we write out the syntax, is this. Neither drug A nor drug B are being looked at by themselves. Neither of them are being held constant. So it doesn't really make sense to include a line for drug A or drug B, right? So instead, we only have this interaction contrast. We have these values here. And again, the order that these values come from is just what we found from the table above. And then which ones are 1 and which ones are -1s are just determined by this table here. That's all. Okay. So, for this lab, we've actually given you all the syntax that you need, right? So not only did we give you these above, but we're giving them to you in the whole syntax, right? All you need to do is copy and paste this syntax into your SPSS syntax. Make sure that nothing changes. When I copy pasted this, for some reason it was double spaced, even though it's not double spaced here. And then SPSS was like, no, you can't do this. Something's wrong. It just put extra spaces between the lines. So watch out for that. Another thing to watch out for, it doesn't matter this time, but it will matter in future interactions and things that we do with SPSS and SAS. They don't like quotation marks. So if I put a quotation mark here, you see how this is rounded, like it's going towards the thing. You know, when people are speaking, this is what they normally look like. SPSS and SAS will say, I don't know what this is. I'm confused. I will stop. So a lot of the times, if you're having a problem, double check that these quotation marks are just like normal flat ones instead of rounded towards something, right? So it could be rounded towards it like that, or it could be rounded the other way. Just double check that. We've had so many problems with how finicky these things can be, and that's such a big one. Okay, so all you need to do is copy paste this syntax. And so I have the syntax right here, and you can see in print, this is what I talked about at the beginning, that test L matrix. This is what gets you the table early on, this one. This is just, that statement here is what gives you this table so that you know the order. So most of the time, you would run the ANOVA, include this in your print statement before you run any of these contrasts, just in order to know what order you have to do things in. So yeah, all you have to do is copy paste and run this. The data set is the same one that we've been using, and I gave you the Windsorized version, and the syntax is based on that as well. So for each of these 5 contrasts, we want you to report the findings, interpret the results. So, for example, I can bring this out. So here's one of my contrast coefficients. This is custom hypothesis tests. So it'll give you this nice index where it says, okay, the first one, this is what we called it. Second one, this is what we called it. Fourth, there's also a sixth one in here. That's just as a kind of example for something else. Here, this is telling you, okay, what values did you actually put in? And then the contrast results give you two different ways to look at it. This first one, this is a t-test. This here, this is an f-test. They will tell you the exact same thing. It is just two different ways of testing a similar thing. So it doesn't really matter. You can typically, I'd say, probably report the F, at least once you get to the interaction coefficients, you have to report the F. But you would say there appeared to be a significant difference between a no dose of drug B and high dose of drug B, with drug A being held at a high dose. Then I'd state the significance. So F199 equals 289, comma, P equals less than 0.001. And then I'd say, the A no dose of drug B with high dose of drug A was significantly lower, and then put in the mean and standard deviation, than high dose of drug B with a high dose of drug A. So that's kind of what I want for this. Will you be required to show your work? No, again, this is just for you so that you can get some practice writing out stats. The final contrast, so that interaction contrast, if it's significant, you want to report the source of that difference using additional contrasts if necessary, right? So you want to say, okay, if this is significance, where is that difference coming from? And if you might need to do additional contrast, you might already have the answer in there. So that is everything for lab on Monday. I hope that this was understandable. This is one of the more confusing things once we start getting into it, but I promise it'll get better. That's part of why we give you the syntax here. It's a bit easier, I find at least, to modify syntax given than try and figure it out myself. So here you go, and I will see you on Monday with the interpretation of the results and any questions that you have. Okay, see you all then. Enjoy these last few days.